morning class. My name is Devanshu Dev. You can call me Deba or my physics teacher. And friends, during this entire lockdown series of videos, I was focusing on the subject matter so far. Until one of my students in his feedback wrote that he loves my class, but the virtual class he finds difficult as this is lacking in eye contact. Alright, that's true. When you look into the eyes of a person, you communicate confidence and believe in your point of view. I respect his views, so punching some of my photos in the video, though longer eye contact is associated with trust, good feeling and rapport, all of which are important leveraging qualities rather. But as my technical knowledge acquired so far is not sufficient to enable this level, just now I cannot do it, but I promise I will improve upon this quality during this lockdown time. Happy learning time. So my today's lesson is step-by-step numerical solving on capacitor combination and its trick of solving. Let's see. At the beginning you have to remember some of the formulae. There are only 2 points I'm taking today. One is series, another is parallel capacitors, and the question related to that. Now the first one is the series combination. Two capacitors connected in series, C series is equal to C1 into C2 divided by C1 plus C2. It's a very handy formula. Remember, this is not applicable for more than two capacitors. When there are two capacitors connected in series, here you will be having the voltage distributed. The charges are same, but the voltage is distributed. So the voltage difference across C1 is C2 by C1 plus C2 into V. V is the total potential drop or total potential difference across the series combination. And C2 is equal to C1 by C1 plus C2 into V. I'll also talk about parallel. Formula for parallel combination is two capacitors C1 plus C2. You can see the diagram how the parallel combination and series combination are drawn. C parallel is equal to C1 plus C2. Here the voltage across each of the capacitor would be remaining the same, but the charges will be different depending on the capacitor. In my capacitor chapter you must have already learnt about it. So Q1 is equal to C1 by C1 plus C2 into Q, and Q2 is equal to, Q2 is the charge in C2, is C2 by C1 plus C2 into Q. These two formulae you need to remember to begin with or write it down somewhere. My first question is, find the equivalent capacitance of the capacitor shown in the figure. You can see this is a combination of series and parallel both. Two capacitors 10 microfarad and 30 microfarad are in series, and this series combination is in parallel with 20 microfarad. As a solution, what to do first? Step 1. Two capacitors 10 microfarad and 30 microfarad are connected in series. We can replace them with an equivalent capacitor with the capacitance C equivalent say. Now this 10 microfarad and 30 microfarad you have seen they are in series. So 10 microfarad and 30 microfarad series combination will be C equivalent, 1 by C equivalent. The formula is 1 by C1 plus 1 by C2, or you can use the C1 C2 into C1 plus C2. Other the formula you have to you can use, then the value of 1 by C equivalent comes out to be 4 by 30, and C equivalent will be inverse of that. So inverse of 30 by 4 is equal to 7.5 microfarad. Now we have two capacitors 7.5 microfarad and 20 microfarad connected in parallel. See the second of this adjacent figure. The equivalent capacitance can be found following expression. Now it is a parallel combination. So parallel combination C parallel is equal to C1 plus C2. So 7.5 plus 20. So the value would be how much? Yeah, 27.5 microfarad. So it was pretty simple. Let me go to the next question. Find the equivalent capacitance of the three capacitors shown in the figure. Now this is a little harder. 30 microfarad and 10 microfarad, they are in parallel first, and then you have to do the series combination. Now how to do it? You at first two capacitor will be taking 10 microfarad and 30 microfarad in parallel, so you'll be getting the value as 40 microfarad. 40 microfarad. Okay, so this is the combination of 30 and 10. Now they are in series with 20 microfarad. Now let's see. This 40 microfarad is connected in series with 20 microfarad. Then we have capacitor 40 microfarad and 20 microfarad in series. So what will be the expression? The expression is C1 into C2 by C1 plus C2, or 1 by C equivalent is equal to C1 1 by C1 plus 1 by C2. So the formula will come out to be 1 by C equals 3 by 40. So what will be C equivalent? C equivalent will be 40 by 3 microfarad is equal to 13.3 microfarad. That's also pretty simple. This is a level 1 question. Three capacitors. But this time we are not finding out capacitance, we are finding out the charge. Students, remember, when you are finding out the charge or potential difference across any of the capacitors, then also the first step would be always to find out what is the equivalent capacity. Of course there are some tricks of solving, but here you can remember that the first step is always to find out the equivalent capacitance, and the three are in series combination. So three capacitors connected in series, you will be finding 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3, 1 by 30 plus 1 by 10 plus 1 by 20, so 11 by 60. So what C equivalent will be equal to 60 by 11. So 60 by 11 microfarad, it is 5.45 microfarad. Now this is the second figure. You can see the second figure is the equivalent capacitance. It is replaced by equivalent capacitance. Now what is the total charge? Total charge is, in the equivalent circuit we have capacitor connected to a battery, and the charge in this equivalent capacitance is Q is equal to C into V. So delta V into C Q will to V. So 5.45 into 10 will give you 44.5 microcoulomb. Remember one point, children, as the 10 microfarad is in series with the combination. In series combination, all the capacitors in series have the same charge. So 10 microfarad will also have the same charge, 54.5 microcoulomb. Question number 4. What is the charge in the 15 microfarad capacitor? Well, it's a very interesting thing. You can see. You can do it with the previous method also, by finding out the equivalent capacitance and finding out the voltage and all these. But this has a small trick. The trick is, across 15 microfarad the voltage is 10 volt. But if the problem will not be same if it is asked what is the charge across 5 microfarad or 8 microfarad, but across the 15 microfarad it is 10 volt. So solution, you can proceed like the previous problem to solve it, but it has an easier solution. The solution is, voltage across 15 microfarad is equal to the voltage of the battery. Then the charge of the capacitor can be found by following expression. Q is equal to delta V into C is equal to 150 microcoulomb. However, if you have any other method in your mind, try it. Now we're going to the little harder question, that is level 2. What is the charge and the potential difference across the 10 microfarad capacitor that I was talking about? The previous problem, it was directly the 10 volt was directly connected across the 15 microfarad. but this time a 10 microfarad is coming in series. So step 1 would be 10 microfarad is connected in series with the battery, then the charge on the capacitor is equal to the charge on the equivalent capacitance. So first step is the finding out equivalent capacitance. Following the steps, already you have practiced a few questions, so you understand how to find out the equivalent capacitance. The first step is 8 microfarad and 12 microfarad, they're connected in series, so the equivalent capacitance is 4.8 microfarad. In the calculation below it has been shown. Now this 4.8 microfarad and 15 microfarad again in parallel, so equivalent capacity C1 would be equal to 4.8 microfarad plus 15 microfarad that is 19.8 microfarad. Now this is the C1, 19.8 microfarad. Now 19.8 microfarad is again in series, so you'll have to once again connect them in series and you will be getting 1 by C equivalent equal to 0.15. Now 0.5 we have to invert for finding out the C equivalent. So how will you do it? 0.15 means 0.15 is 15 by 100. So C equivalent to be 100 by 15 is 6.64 microfarad. Now we can find the charge on the equivalent capacitance. The equivalent capacitance is 6.64 microfarad and 12, so that is 79.68 microcoulomb. As 10 microfarad is in series, so the charge through it is 79.68 microcoulomb. So this is level 2, but not that tough. What is the charge on the 5 microfarad capacitor? Yeah, that was the type of question I was talking about in my last to last question. This time you cannot directly take it is 10 volt across 5 microfarad, because 10 volt would be now divided into two parts, V1 and V2. You can easily find it out with the help of the formula I have just shown, but here I will be doing it in the conventional method. Explanation: two capacitors 5 microfarad 5 microfarad are in series. It means that the charge on the capacitors are same and are equal to the charge on their equivalent capacitor. The equivalent capacitance is 5 microfarad and 8 microfarad. Yes, C1 into C2 by C1 plus C2. Already you have expertised. So it is the okay, 13 by 40 for C equivalent, 1 by C equivalent, and C equivalent will be inversion of C 1 by C equivalent is equal to 3.1 microfarad is 40 by 13. Now this 3.1 microfarad in the second diagram you can see this is in parallel with 15 microfarad. So the voltage across equivalent capacitor is 3.1 microfarad, because 3.1 microfarad is directly in parallel with 10 volts, so its voltage is 10 volt. So Q would be equal to CV, C equivalent to delta V, so it will be 3.1 micro is 10 to the power minus 6 into 10, so it will be 31 microcoulomb. This 31 microcoulomb will be passing through both 5 microfarad and 8 microfarad. So this charge is the same as the charge on 5 microfarad and 8 microfarad. So what is the total charge in the 5 microfarad? It will be 31 microcoulomb. I hope you like this question. Now a little harder. What is the equivalent capacity between A and B and A and D? Well, children, you need to see the diagram. A and B, when you are taking, you have to invert this and ignore D. So in that case, A So at A and B you will be having 5 and 3.5 in series. Again 0.75 and 15 in parallel. Again equivalent of 0.75 and 15 is in series, then all are in parallel. Try it. And when it is between A and D, actually this type of technique has got some name. It is called stretching technique. This type of stretching technique and shorting techniques I have explained in my second video, which is meant for some of the entrance based questions, but here I am confining my lecture within the arena of the CBSE based question. Okay, another question now. What is the charge on the charge and the potential difference across the 12 microfarad capacitor? So similarly, this is exactly the same question as you have done in your question number 6. So rather, question number 6. Now here you can at first find out the equivalent capacitance of 8 micro, 12 micro, that is in series, then parallel, this parallel with 15 microfarad, this series and parallel combination together will be again in series with 10 microfarad. From that you will be finding out the total charge Q is equal to C into delta V, and that Q will be once again distributed across the combination of 8 microfarad, 12 microfarad and 15 microfarad. Now across 12 microfarad the charge is the total charge that is flowing across 8 microfarad and 12 microfarad. Try this question and thank you and keep well.